I'm Roman Fergas from Team MPPT, and I'm speaking on behalf of other group members named Rushi Delau and Milan Furia. This is a soft proof of concept of maximum power point tracking with the MSP 432. We use several bits of hardware in this demonstration right here. Right now, the sun is incident upon the front face of the panel, and the panel is constantly tracking at 1 second perturbations where the maximum power point of the sun is. Rushi will zoom in on the hardware now. We have basically a servo motor circuit on this breadboard and a couple of fault capacitors to make sure that enough current is delivered to the servo motor. We also have a voltage divider where the voltage is coming in and being measured by the MSP 432 because the voltage had to be attenuated down to a level that the MSP 432 could handle. Also, we're measuring current across the current sense resistor that's at about 2 mega ohms right now, so that we could sense the very small, almost quiescent current levels that are coming out of the solar panel. In terms of hardware on the car, we use the fuel tank booster pack that has a DC to DC converter, as well as a fuel tank chip that monitors battery life. We use the MSP 432. That is obviously the brains of the project. And we also used on top the DRV 8848, which we have not been able to get working for this demonstration, but that will control the drive shaft in the bottom. As far as the servo motor on top, we're using the PWM output of the MSP 432 to control that. Not shown in this demonstration is also a light detector circuit that would go on the front face of the vehicle. If the vehicle happened to go under a tree or was obstructed by any other kind of occlusion, the light detector circuit would notice this, and it would duty cycle up our perturbation algorithm and try to quickly evade any obstacles that it was underneath. Moving forward with this project, what we'd like to do is some applications-based stuff and some optimization. The only thing that you can really change once the base algorithm is written is how much you duty cycle the algorithm, or how much you perturb and then observe. Basically, what you want to do is you want to look at incident light coming into the panel and how much work or how much power that you're using to actually perturb the thing at a certain duty cycle rate. So you take data over the course of maybe weeks or months, and then you would finally find the optimal duty cycle based on a given solar field that you're measuring. Which brings me closer to applications. Applications of this could be a solar field that's intelligent. You're using MPPT chips or MPPT controllers. Usually has a controller on either every panel or every grouping of panels, where every controller is basically the master in this relationship. Now, if you had a car like this that could move through a solar field intelligently and constantly data log and send information to its slave, basically panels that were in the field, you'd have a low-cost, MCU-driven, basically maximum power point tracker working a whole solar field that can harvest a lot of energy, and can harvest a lot more energy if it's intelligent, rather than just at the same pitch angle.
So what we've done now is to create the case where the solar panel starts where the sun is not incident on the solar panel, and it would then have to go the opposite direction in order to obtain the sunlight. So as you can see, where it started from the rightwards direction, it's not moving towards the left, and it has passed the 90 degree mark.
Some of the issues that we ran into in this project as well was the resolution of the input ADC and measurement stability. Even though the voltmeter is reading mostly higher readings whenever this moves in the correct direction, the MSP 430 always has to make the MSP 432 rather always has to make a decision on those values that come in, and sometimes if those values are unstable, the controller will move the panel in the wrong direction. A few mistakes are made right now, but there are mistakes, and those could be mitigated in the future by taking ranges of values or multiple values at each position of the panel, and then averaging them or filtering them somehow to get a more reliable value, rather than just relying on one or two values at every angle.